All right. So today I'm going to be showing you the Snap Circuits Lab number 7 for the in-person lab. First of all, let's look at the safety warnings. So number 1, confirm all components are going in the correct direction before activating it to avoid causing damage. Some components can short circuit or melt if they're put in the wrong direction. Other things can go both directions, so it just depends on the component. Return all parts to the correct locations according to the diagram. So this is just like cleanup afterwards, basically. This is a screenshot or an image, a photo of the snap circuit set, which I'm going to show you in just a moment. Project number 1 is the electric light and switch. Build the circuit in the diagram. Be careful to arrange each component in the correct direction. When the switch is closed, it completes the circuit. When the switch is open, the current can no longer flow back to the battery, so the lamp goes out. So we're going to build the first project, and that's referring to the guide here. So the first project is a simple circuit with a lamp and a switch. So we're going to build this circuit. All right, so I'm going to start by placing the battery pack on the circuit board. And then I'm going to start placing my components. So I have my lamp 1 should be placed here and across from the switch here. And then everything's just connected with pieces. So these little blue pieces act as your wire connectors. Looks like I'm off by 1 square here. Scoot this over. Okay, and so the back of this has, this essentially wires this to this, and so instead of dealing with wires, you have these little pieces. So we're just going to connect the whole circuit in a loop. Okay. In the instructions, it says to now go ahead and turn on the switch. So turn on the switch. Hopefully you can see that the lamp came on when we turned on the switch. When we turn off the switch, the lamp turns off. So the next part of the lab is asking you to build the same circuit on FET. And the reason for this is I want you to see the way current flows. Okay, so I'm just going to build out a circuit the best I can, the same as the other one I just did. Okay. Now, I could adjust my settings to make all of the components have the same values, but ultimately that's not really the point of this. The point of this is just to see what a closed and open circuit actually is. So currently, this is actually an open circuit. So right now, this is an open circuit and the FET is an open circuit. Notice that there's no light bulb on and that there's no movement of current in the wires in the circuit. When I close the switch, okay, now the electrons flow around the circuit and the light comes on. So in circuitry, this is a closed circuit because the loop is closed. So if you look right here at your switch, so a closed switch is an on switch, and an open switch is an off switch. And that's a little bit counterintuitive. It feels a little bit backwards. But if you think about it as a loop, if you have a closed loop, then you can have a flow. But if you have an open loop, like a broken loop, then you don't have electricity moving. So this is off and this is on. Okay. All right. Question number 1 says, build the same circuit in the PhET simulation we just did. Share a screenshot of the circuit you built. So I took a screenshot a moment ago, and I'm going to click on show my work. And I'm going to insert the image I took. Okay, and then the rest of the question says to explain the difference between an open and a closed circuit. So here you will describe the difference between an open and closed circuit based on what I just discussed with you and your observations. All right, complete project 5, the lamp and fan series. So now we're going to build project 5 from the book. And so we're going to build this one now. Okay. All right, so we have battery pack, switch, lamp, motor, and it's in one single loop. We call this a series circuit. Okay, so I just turned it on and the bulb comes on, but you can see that the motor really doesn't, it turns a tiny, tiny bit, but not enough to really go, okay? So it says, how can a lamp indicate when the fan is running in a series circuit? Well, when the lamp is on, the fan should be on too. Unfortunately, I don't think there's enough juice in these batteries to actually make the fan spin, but you can see that when the switch is on or the switch is closed, meaning the same thing, that the lamp is on and the fan tries to come on. All right, so the next project says complete project 6, the lamp and fan in parallel. So it's a similar configuration. I'm just going to rearrange the pieces to make 2 loops that are built into each other instead of one single loop. Okay, so for this one, okay. All right, this time the fan and the light are in parallel. And the difference is that now there's 2 circles. So you have battery, switch, wire, 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 bulb, wire, 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 battery. So the bulb is on a separate loop by itself. And then there's this other loop that goes up around through the motor for the fan and then goes all the way back around to the battery. So both parts, both components, the lamp and the fan, are connected to the battery directly without having to go through each other. So let's see if we notice a difference in the motor. Remember when we did series, the motor really couldn't spin very well. So let's see if we get a better result. Much better result. Notice the fan is spinning quite briskly. So we get the light on and we get the fan on. So how can an indicator light be connected without affecting the current? Move this up. Without affecting the current. Current can be observed by the speed of the fan and the motor. So note that when we had a series circuit where we had one single loop, like in this picture here, that the bulb came on, but there wasn't enough juice to make the fan run because they're on the same circle. But when we put them on two separate circles, they both could run. The bulb was a little bit brighter. I don't know if you could tell, but the bulb was a little bit brighter, and the fan definitely worked so much better. So that's how we can tell that the current is going faster when we have a parallel circuit versus when we have a series circuit. For the purposes of this video, I'm going to do Project 15 Musical Doorbell. So if you're doing this remotely, you will need to put that down here as the project you chose, Project 15 Musical Doorbell. So I'm going to build it with you to show you what that will look like. And I'm going to pause it here and there just to keep it from being too long. Okay, so I'm working on my first layer. I have my batteries, I have switch 1, I have my music component, and I have some wires starting. Now I've added the speaker and the light diode. I'm now going to add the press switch, switch 2, which will go here. And I'm going to add the resistor here. And the next stage is just to connect everything else with the wire connector. I've now connected all the remaining pieces and switches. So let's see what we got here. So we're going to turn this switch on. Nothing happens. Turn this switch on. Okay. Going to check our connections because that didn't work. All right, after checking the diagram, it turns out I had left one wire piece missing here connecting to the battery, so I didn't have a complete circuit. All right, let's try that again. So now I'm going to start by turning on the slide switch. Nothing happens. Hold down the button switch. So we have our diode that came on, our little diode light that came on here. This component played the music. The speaker projected the sound, so you can see the speaker here. And with just this switch on, it doesn't do anything, but like that. All right. I have now added the title of the project we did, number 15, Musical Doorbell, and a screenshot or a photo of the circuit we built. So you can pause the video and take a screenshot here to put that into your assignment. All right, don't forget to describe what you observed whenever I played the circuit for you, and just a brief observation.